Imagine if the very air around you, the ground beneath your feet, and even the thoughts in your head were all singing a silent song. What if the invisible hum of the universe held secrets that could change everything we know about reality? This isn't science fiction. It's the profound idea at the heart of vibrational reality. From the tiniest subatomic particles to the swirling galaxies light years away, everything is in a constant, restless dance of motion. It's a foundational principle. The universe isn't just full of stuff, it's full of vibrations. And understanding this dance is key to unlocking some truly mind-bending concepts. Today, we're going to pull back the curtain on this unseen symphony, exploring how the known science of crystal vibrations might be far more intertwined with the ambient thermal energy of our world than most people realize. We'll delve into the hard science, then venture into a fascinating what-if scenario that could reshape our understanding of how things truly connect. At the core of this vibrational symphony are crystals. You've probably seen them, beautiful objects sparkling with light, often admired for their unique shapes and colors. But beneath that surface beauty lies an astonishing scientific reality. Crystals are highly organized powerhouses of atomic precision. Imagine a vast, perfectly ordered army of atoms, each one knowing exactly where it belongs, locked into a lattice structure. Because of this incredible order, crystals don't just sit there, they vibrate. Each crystal, depending on the type of atoms it's made of and how they're arranged, possesses a unique, specific resonant frequency. Think of it like a finely tuned musical instrument, each one ready to play its own note. This isn't some mystical belief, it's established science. We've known for a long time that crystals, like quartz, will vibrate at specific frequencies when you poke them, squeeze them, or even apply an electrical field to them. This phenomenon is called piezoelectricity. It's the reason why your quartz watch keeps such accurate time. A tiny crystal inside is squeezed by an electric current, vibrating at a super precise rate, ticking off the seconds. Or think of the spark igniter in a gas lighter. You press a button, a tiny crystal gets stressed, and boom, it generates an electrical spark. It's a two-way street. Mechanical stress creates an electrical charge, and an electrical charge creates mechanical stress, and crucially, vibration. This well-documented science gives us a solid footing to understand how crystals interact with their environment, not just by touching, but through the invisible language of vibration. They are, in essence, natural transmitters and receivers of vibrational energy. Now, let's zoom out a bit and consider something equally fundamental. We all know what hot and cold feel like, but what's actually happening at the tiny, invisible level? Here's the kicker. Temperature isn't just a number on a thermometer. It's a direct measure of how much stuff is jiggling. Specifically, thermal energy is the kinetic energy of molecules. It's the constant, chaotic dance of atoms and molecules bouncing off each other, spinning, and moving around. If you've ever seen water boiling, you're watching molecules going absolutely wild, vibrating so hard they break free from their liquid bonds and turn into steam. When something is cold, its molecules are still moving, but they're doing a much slower, calmer shuffle. So every single object around us, from the chair you're sitting on to the air you're breathing, is undergoing this internal, ceaseless dance of molecular vibration, all driven by its thermal energy. It's a fundamental, inescapable aspect of our reality. Here's where things get really interesting, and where we step from the firmly established into the realm of fascinating scientific curiosity. We have crystals with their incredibly precise, resonant vibrations, and we have everything else filled with chaotic, thermally driven molecular vibrations. The question, the big what if, is this: could the specific, ordered vibrational frequencies of crystals somehow interact with the much more chaotic, ambient thermal energy of their surroundings? Could there be a mechanism where crystals don't just respond to external energy, but actively influence or harmonize the thermal jiggle around them? Imagine a crystal not just having a vibration, but subtly broadcasting it into the energetic sea of thermal motion that surrounds it. Could this broadcast act like a kind of tuning fork, gently nudging the nearby molecules into a more coherent, or perhaps even a more ordered, state of vibration? This interaction could manifest in several ways. Perhaps it's a direct transfer of vibrational energy, where the crystal's stable frequency provides a pathway for the ambient thermal energy to align itself. Or maybe it's a modulation of molecular motion, where the crystal's presence creates a kind of energetic ripple that subtly changes how molecules move, even if it's just for a fleeting moment. It could be like throwing a tiny, perfectly round pebble into a puddle of randomly splashing water, and for a brief moment, the ripples from the pebble create a fleeting pattern in the chaos. This isn't about crystals magically changing the temperature of a room, at least not in a way we'd immediately feel. We're talking about something far more subtle, a nuanced interplay at the molecular level. Think of it less like a sledgehammer and more like a whisper. If a crystal's highly ordered atomic structure and resonant frequency can act as a kind of stable anchor in a sea of thermal motion, what if it could impart a degree of its own order to its immediate environment? Consider the implications. If crystals can somehow interact with and subtly influence ambient thermal energy, even in ways we don't fully understand yet, the potential applications could be enormous. We might unlock new methods in material science, designing composites that react to temperature in entirely novel ways. Imagine energy harvesting technologies that don't rely on massive temperature differences, but on subtle vibrational harmonizations. We're not just talking about more efficient solar panels. We're talking about fundamental new ways to understand and interact with the energy that's always present around us. It would push us toward a deeper understanding of the fundamental nature of reality itself, revealing more about how everything is interconnected. The exact nature of such an interaction remains a profound subject of exploration, a frontier where physics meets philosophy. We have the established science of crystal resonance and the undeniable reality of thermal molecular vibration. Bridging these two, exploring the what-if of their subtle interplay, could be the key to unlocking insights that go far beyond our current understanding. This exploration of a hidden vibrational symphony promises to reveal new depths to the interconnectedness of our universe, showing us that even the most seemingly inert objects might be singing a quiet song that influences everything around them. If you found this journey into the unseen world of vibrations fascinating, you'll definitely want to check out our next deep dive into the mysteries of the universe.